Mega bunkers, the last refuge. The concept of the ultimate refuge. Since the dawn of civilization, humanity has sought ways to protect itself from the threats of the outside world. From medieval castle walls to mountain fortresses, each era has engineered its own defenses. Yet the dangers of the modern age, nuclear war, pandemics, climate collapse, cyber attacks, demand something far beyond stone walls and steel gates. This is where the idea of the mega bunker emerges, a fully autonomous underground fortress designed to keep its inhabitants alive for years, perhaps decades, completely sealed off from the surface. The concept itself isn't new. During the Cold War, superpowers carved massive subterranean complexes to ensure the survival of their leaders and strategic forces in the event of nuclear war. The United States built sites like Cheyenne Mountain, a fortified command and control center deep within the Rocky Mountains, while the Soviet Union constructed equally imposing underground facilities near Moscow and in remote parts of Siberia. These bunkers weren't just shelters. They were nerve centers, built to coordinate military and political responses even in the aftermath of global catastrophe. What makes the mega bunker of today different is its purpose and its clientele. Once the exclusive domain of governments and militaries, these extreme shelters have now entered the private market. Billionaires, corporate magnates, and even small groups of ultra-wealthy individuals are commissioning bunkers that rival and sometimes surpass the sophistication of their military predecessors. The reason? The growing sense that the next global crisis may be sudden, unpredictable, and devastating. The 21st century has already provided multiple reminders of how fragile our systems are. The COVID-19 pandemic exposed weaknesses in global supply chains. Increasing geopolitical tensions have brought back the specter of nuclear confrontation. Climate change has intensified extreme weather events, pushing some regions toward instability. And in the shadows, cyber warfare has the potential to cripple critical infrastructure in seconds. For those with the means, waiting for disaster to strike without a plan is simply not an option. A true megabunker is far more than a thick steel door in the side of a mountain. It is an engineered ecosystem. Beneath layers of reinforced concrete, blast-resistant corridors, and sealed airlocks lies a carefully designed network of living quarters, food and water reserves, medical facilities, and command centers. Some are vast enough to house hundreds of people. Others are built for smaller, more self-sufficient groups. Every square meter is calculated for efficiency and survivability. One defining characteristic of modern megabunkers is autonomy. These structures are built to operate independently from the outside world, using renewable power sources, advanced air filtration systems, and underground water reservoirs. In some cases, they incorporate hydroponic farms and aquaponic systems to produce fresh food on site. The goal is simple but critical: survival without external resupply, even if the world above becomes permanently uninhabitable. The cultural perception of bunkers has also shifted. Once seen as symbols of paranoia or relics of the Cold War, they are now marketed as luxury life assurance solutions. Some developers present them not as grim shelters, but as exclusive sanctuaries, complete with cinemas, gyms, art galleries, and even swimming pools. In these spaces, survival is reframed as a continuation of comfort, rather than a retreat into austerity. This blend of necessity, engineering brilliance, and luxury marketing has transformed the megabunker into both a practical survival tool and a status symbol. Whether intended for government continuity or private refuge, each one represents the same unspoken acknowledgement. The world we live in is unpredictable, and for some, the safest place to be when disaster strikes is deep below the surface. Government giants. When it comes to mega bunkers, no private facility, no matter how lavish, can truly rival the sheer scale, secrecy, and strategic importance of those operated by governments. Built not for comfort but for survival at the highest levels of national command, these underground fortresses are designed to function as the beating heart of a nation during its darkest hours. In the United States, one of the most famous examples is Cheyenne Mountain Complex in Colorado. Originally constructed during the Cold War, this massive installation was built into a granite mountain to withstand the shockwave of a 30-megaton nuclear blast. Behind its blast doors, each weighing over 20 tons, lies a network of tunnels and chambers housing command centers, living quarters, and life support systems. It was designed as the nerve center for NORAD, North American Aerospace Defense Command, able to coordinate the defense of North America even if cities above were reduced to rubble. Though much of its role has shifted to other facilities, Cheyenne Mountain remains operational and on standby. Across the globe, Russia's network of government bunkers is equally formidable, though shrouded in secrecy. Facilities such as the Yamantau mountain complex in the southern Urals have long been the subject of Western speculation. Satellite images and intelligence reports suggest that Yamantau is a vast underground city potentially capable of housing tens of thousands of people. Officially, Russia remains tight-lipped about its purpose, but analysts believe it serves as a command post, storage site for strategic weapons, and a relocation hub for government officials in case of nuclear war. China, too, has invested heavily in underground command infrastructure. Beijing is rumored to be connected to an extensive subterranean network, including hardened facilities capable of withstanding conventional and nuclear strikes. These bunkers not only protect leadership, but also secure critical military assets such as missile command systems and communication hubs. The concept behind these government giants is known as continuity of government, COG, ensuring that, no matter what happens, the chain of command and the ability to govern remain intact. This means more than simply surviving. It means having the tools, communications, and personnel in place to respond to crises, deploy military forces, and maintain civil order even under catastrophic circumstances. Security in these installations goes far beyond the obvious. Multiple layers of authentication are required to access critical areas, with biometric verification, coded key cards, and constantly monitored checkpoints. The interiors are self-contained, featuring air filtration systems capable of removing nuclear, biological, and chemical contaminants, independent water supplies, and redundant power grids, often shielded from electromagnetic pulses, EMPs, that could disable electronics elsewhere. While these bunkers are designed to be impregnable, their greatest defense is secrecy. Precise blueprints, operational capacities, and even the identities of key personnel are closely guarded. In many cases, the public only learns about the existence of such facilities decades after they are built, if ever. For all their technological sophistication, these bunkers also serve as powerful symbols. They send a message to adversaries. Even in the event of total devastation, the state will endure, its leaders will survive, and retaliation will be inevitable. This psychological dimension is as integral to their purpose as their physical defenses. Yet, despite their awe-inspiring capabilities, government megabunkers face one limitation. They are designed for a select few. The vast majority of the population will never see the inside of such a facility, let alone benefit from its protection. That exclusivity has given rise to a new phenomenon, the rise of the private megabunker industry, where survival has become a commodity for those who can afford it. The elite of private bunkers. In the past, the idea of a heavily fortified underground refuge was reserved for presidents, prime ministers, and military generals. Today, however, the ultra-wealthy are commissioning megabunkers that rival, and sometimes exceed, the sophistication of government facilities. These are not grim survival shelters. They are private sanctuaries, engineered to preserve both life and luxury in times of global crisis. One of the most famous examples is Vivos Europa 1, a vast private bunker complex in a former Cold War munitions depot in Rothenstein, Germany. Carved into solid bedrock, the facility offers 21 private suites, each customizable to the owner's preferences. Residents can install everything from lavish living rooms and gourmet kitchens to wine cellars, gyms, and even art galleries. Beyond individual quarters, the shared spaces include restaurants, theaters, swimming pools, and medical centers, all secured behind multiple blast doors and manned by trained security staff. In the United States, the Survival Condo Project has transformed a decommissioned nuclear missile silo in Kansas into a vertical luxury fortress. Each condo unit is equipped with modern interiors, high-end appliances, and private storage, while shared facilities feature a hydroponic farm, aquaculture tanks, a medical clinic, a library, and a dog park. The silo's original blast doors and deep underground structure provide unparalleled protection, while its amenities ensure that residents can maintain a comfortable lifestyle even during extended isolation. Other facilities, like the Oppidum in the Czech Republic, market themselves as the largest billionaire bunker in the world. This site blends maximum security with opulence: marble floors, chandeliers, spa facilities, and secure meeting rooms for high-level business dealings, all underground. These projects cater to an elite clientele who see survival not as mere endurance, but as the preservation of status and comfort. The business model behind these ventures reflects a growing market for life insurance you can live in. Developers target individuals and families with the means to pay millions for guaranteed safety, offering confidentiality agreements and discreet site visits. Security is tailored not only to repel physical threats, but to ensure complete privacy. The location of many private bunkers is kept secret even from non-essential staff. In terms of defenses, private megabunkers often match their government counterparts in technological sophistication. Multi-factor authentication systems combine biometric scans with encrypted passcodes and mechanical fail-safes. Air filtration and water purification systems are designed to function for years without resupply. Communications arrays link residents to global news and encrypted satellite networks. One notable difference is customization. While government bunkers are uniform and utilitarian, private ones are highly personalized. For the ultra-wealthy, a bunker isn't just a refuge. It's an extension of their identity, a place where their preferred art hangs on the walls and their favorite vintage wines are within arm's reach. Critics see this as the ultimate symbol of inequality, a world where survival is literally gated, and only those who can afford the entry fee are guaranteed protection. Proponents argue that private bunkers relieve pressure on public resources and that their owners have every right to protect themselves and their families. Regardless of the debate, one thing is certain: the rise of private mega-bunkers has transformed survival from a grim contingency into a luxury experience. And behind the plush interiors and discreet entrances lies a core truth. These fortresses are designed with the same underlying goal as their military counterparts: to remain operational and secure no matter what happens on the surface. Technologies and autonomy. What sets a true mega-bunker apart from a mere shelter is its ability to sustain life independently for extended periods, not just days or weeks, but months or even years without any contact with the outside world. Achieving this level of autonomy requires a seamless integration of engineering, environmental control, and security systems, all working together in an underground ecosystem. The first priority is air. Advanced air filtration systems in modern bunkers are designed to protect against nuclear fallout, chemical agents, and biological contaminants. These systems often feature multiple filtration stages, including HEPA filters, activated carbon, and specialized chemical absorbers. Many government and high-end private bunkers also use overpressure systems, maintaining a slightly higher air pressure inside to ensure that any leaks push air outward rather than allowing contaminated air to enter. Water is another critical factor. Deep underground wells, shielded from surface contamination, supply clean water to the facility. In some cases, water is also recycled through advanced purification systems that can remove pathogens, heavy metals, and even radioactive particles. Redundancy is key. Multiple sources and backup systems ensure that a single point of failure cannot compromise the entire supply. Food production and storage are equally vital. While most bunkers store large quantities of freeze-dried and canned goods, the most advanced incorporate on-site agriculture. Hydroponic farms, aquaponic systems, and LED-lit grow rooms allow for the cultivation of fresh vegetables and herbs year-round. Protein sources can be supplemented by fish farms or lab-grown meat facilities, creating a closed-loop food system that minimizes reliance on stored rations. Energy independence is achieved through a mix of technologies. Diesel generators remain common for backup power, but long-term sustainability depends on renewables such as solar panels, often hidden on the surface above, geothermal systems, and even small modular nuclear reactors in certain government facilities. Battery banks and energy management software regulate consumption and ensure uninterrupted power to critical systems. Security, of course, extends far beyond locked doors. Modern bunkers employ integrated surveillance networks combining motion detectors, infrared cameras, seismic sensors, and biometric checkpoints. AI-assisted monitoring can detect unusual patterns of movement or environmental changes, triggering automated lockdown protocols. In some cases, defensive measures include remotely operated barriers, drone patrols, and even automated deterrent systems. Digital protection is just as important as physical. The control systems that regulate air, water, power, and security are often air-gapped, physically separated from public networks to prevent cyber attacks. Encrypted communications allow occupants to stay connected with the outside world while keeping sensitive information secure. Blockchain-based access logs ensure that any attempt to manipulate entry records is immediately flagged. All of these systems are designed with redundancy in mind. Every essential function, from power generation to medical facilities, is duplicated or triplicated. If one component fails, another can take over instantly. This redundancy extends to personnel as well. Staff are cross-trained in multiple disciplines, ensuring that no single absence can disrupt operations. Ultimately, the goal is self-sufficiency. A mega-bunker must be able to survive not only a catastrophic event, but also the prolonged instability that may follow. Whether protecting a nation's leaders or a private group of residents, the design philosophy remains the same. Anticipate every possible threat, prepare for every scenario, and build a system so resilient that it can outlast whatever catastrophe unfolds above. The future of mega-bunkers. As threats evolve, so too must the shelters built to withstand them. The mega-bunkers of the future will not simply be deeper, stronger, or more luxurious. They will be smarter, more adaptive, and potentially indistinguishable from science fiction. The next generation of underground fortresses is already taking shape, driven by advances in materials science, artificial intelligence, and autonomous systems. One promising development is the use of self-healing materials. These advanced composites can automatically repair cracks or minor damage, maintaining structural integrity over decades without extensive maintenance. For bunkers, this means increased resilience against earthquakes, blasts, and long-term wear. In high-security applications, these materials could even be engineered to resist cutting, drilling, or thermal attacks. Artificial intelligence will also take on a far more proactive role. Current systems monitor for intrusions or equipment malfunctions, but future AI platforms could autonomously manage all life support and security functions, dynamically adjusting air quality, energy consumption, and even social dynamics among occupants. Predictive algorithms could anticipate threats, simulate response strategies, and deploy countermeasures before danger even reaches the facility's perimeter. Energy shields and directed energy defenses, currently in experimental stages for military use, could one day be adapted for megabunkers. Imagine a vault entrance protected by a field capable of disrupting cutting torches, neutralizing drones, or deflecting small explosive charges. Combined with traditional blast doors, such technology would make physical intrusion virtually impossible. The layout of future bunkers may also become modular and expandable. Using prefabricated segments, a facility could be enlarged or reconfigured over time, adapting to changes in population, mission, or available technology. Some concepts even envision hybrid habitats, bunkers that connect seamlessly to underground cities, spaceport facilities, or subsea installations, creating networks of interlinked refugees. On the life support side, innovations in vertical farming and bioreactor technology could enable complete dietary self-sufficiency. Closed-loop aquaponics could provide both fish protein and fresh produce, while synthetic biology could allow on-demand production of medicines, vaccines, and essential nutrients without relying on external supply chains. Psychology will remain a critical consideration. Long-term habitation underground poses mental health challenges, from isolation to sensory deprivation. The megabunkers of tomorrow will address this with advanced lighting systems that mimic natural daylight, augmented reality environments to simulate open spaces, and even AI-driven social moderators to maintain group cohesion and morale. Finally, geopolitical instability and climate change may push mega-bunker technology beyond Earth itself. The design principles of ultra-secure, self-sustaining habitats are directly applicable to space colonization. Concepts developed for deep underground survival could serve as templates for lunar or Martian bases, effectively turning today's bunkers into the prototypes for humanity's off-world refuges. In the end, the future of megabunkers will be shaped by a simple truth. As long as the world remains unpredictable, there will be those with the resources and foresight to prepare for the worst. These fortresses will continue to evolve, blending cutting-edge technology with centuries-old instincts for survival. Whether hidden deep in mountains, buried under cities, or standing on alien soil, they will serve the same timeless purpose: to protect life when everything else has been lost. Deep beneath our feet, in places most of us will never see, humanity's ultimate safety nets lie in wait. Whether designed to protect world leaders, shield the elite, or serve as blueprints for survival in space, megabunkers represent the pinnacle of human ingenuity in the face of disaster. They are more than just fortresses. They are a testament to our will to endure. But these hidden sanctuaries also remind us of an uncomfortable truth. In a crisis, survival is rarely equal. The question remains, when the doors close, who gets to be on the inside?